In this video, I'm going to demonstrate how to do the Go for 3.2. I'm going to do examples on 10 and 11. They ask to create an explicit and recursive equations for the given table. So the first thing is you have to determine if it's linear or exponential. And so on number 10, I'm going to look for a common pattern. So the first thing I'm going to look for is if there is a common adding or subtracting. From 5 to 2, it's decreasing. So that means I am either subtracting or dividing. Well, I don't know a number that divides from 5 to 2 nicely, so I'm going to start with subtracting. So I know if I subtract 3, I get to 2. And if I subtract 3 again from 2, I do get -1. So I know that it is linear. And so I know that I have my common difference is 3. It's actually, sorry, it's -3. So we're decreasing. And so I'm going to start by writing my recursive equation. And so I have to pick a starting point, and I'm going to pick just this beginning, f of 1 equals, and at 1 it's equal to 5. And then I have to write the recursive equation. So it'll be f of n equals f of n minus 1, meaning our next term equals our previous term, and it was -3. In our explicit form, we could either write point-slope form or slope-intercept form. I'm going to do both. So to write slope-intercept form, I have to find my y-intercept, and to do that, I have to figure out what the value would be when n is 0. And so I'd have to go figure out if my pattern is -3, what number would have to be when n is 0. And to continue that pattern, it would have to be 8. And so for slope-intercept form, it would be y equals, and my slope is -3. It's my rate of change, my common difference, -3. So I should write it as f of n minus 3n, and then my intercept is 8. Now I could have wrote it using point-slope form and picked a point. So I'm going to pick 1 as my point, and it would be f of n equals, and my slope is still -3, and I'm starting at 1, and so I need to do n minus 1 to say I'm 1 away from 0. I have to go backwards 1 to get to day 0, and at day 1 I have 5, so it would be plus 5. Either way would work. Now for number 11. Right away, most of you should notice that it's doubling, because 6 to 12 is times 2, and 12 to 24 is also times 2. And so once again, for recursive equations, we know in explicit this is an exponential function. And so for my recursive, I'm going to start with my starting point, and this time I'm just going to pick day 3, and day 3 is 24. And the pattern is multiplying by 2. So it'll be f of n equals f of n minus 1 times 2. Now for our explicit equation, once again, we can choose to use when n is 0, or we can use when n is 1, 2, or 3, just like we do for linear. But just for practice, I'm going to go backwards. If I were to go backwards, what value would have to be to continue this pattern of timesing by 2? Well, it would have to be 3. And that would continue our pattern of doubling. So to write it using the 0 term, what I would do would be I would start with f of n equals, and my rate is 2, and since exponential has x as an exponent, and it's exponential, so it's repeated multiplication, and my starting point is 3, so times 3. If you didn't want to go backwards to day 0, you could have used day 1, and the way that would have looked would have been f of n equals, well, we're still doubling, so it's still 2, but I'm not going to use day 1, I'm not going to use day 0, I'm going to use day 1, so I have to do x minus 1, and then it would still be, in this case, not times 3, but times 6, since on day 1 I have 6. So times 6. And either way would work as your explicit equation.